Welcome to the ENFUSE module on power measurement. Throughout your engineering career, regardless of discipline, you may need to conduct a variety of measurements. Measurements that provide you data upon which you'll make decisions related to the system you are working on. This module considers several different measurements that provide information related to the electrical parameters you've discussed in class, such as voltage, resistance, and current. We will put these measurements to use for the purpose of understanding the power dissipated by components in a circuit. By now you've probably heard much talk of the smart grid. Fundamentally, the smart grid overlays a communications network onto the existing power grid. So what is this communications network for? It's to relay data related to the power used throughout the grid and to provide an avenue to manage the various loads and sources in the grid. For instance, if it's known that cloud cover will soon impact the output of a solar farm, then other power sources can be ramped up, or load, such as electric vehicle charging, can be delayed or decreased. Data sources in the smart grid are distributed throughout the network. One type of data source is a PMU, or power measurement unit. This device provides real-time synchronized measurements of voltage, current, and power factor at various key points in the grid. These measurements are conducted at very fine intervals in time using sampling rates exceeding 2 kHz. These devices use GPS time to ensure they are all sampling at the same instances, regardless of locations, and thus are also known as synchrophasers. Another type of device is the AMI, which stands for Advanced Metering Infrastructure. This device may have already appeared on your home and is more commonly called a smart meter. This meter differs from its predecessors in that your power use does not have to be read manually, but is sent automatically to the power company. The advantage is that data can be relayed much more frequently, for example, at 15-minute intervals, versus a monthly manual reading. This new data can be used to better understand consumer loads and thus allow the power company to be more efficient in its power generation. Smart meters are also seen to be a way to network appliances in the household so that peak household power use is reduced. PMUs and AMIs leverage the same measurement techniques that you will employ in your electrical engineering labs. As you know, power is the product of voltage and current, and these two parameters are related through resistance by Ohm's law. We use a multimeter to measure these values of voltage, current, and resistance. Here's a classic analog multimeter on the right. Critically, for power systems, one needs to understand the phase relationship between voltage and current. Ideally, these two are in phase and therefore power is being delivered most efficiently to the resistive loads. However, real loads are complex as they have unwanted inductance and/or capacitance. Also through Ohm's law, a complex load results in voltage and current not being in phase, thereby reducing instantaneous and average delivered power. We can use an oscilloscope, such as this unit here on the right, to look at these waveforms as a function of time to understand their phase relationships. Hopefully you are or will become familiar with instrumentation more modern than shown on the previous slide. Here we see a digital handheld oscilloscope that integrates into one device the functionality of multimeter parameter measurements, that is voltage, current, and resistance, and oscilloscope waveform analysis, that is voltage versus time. The goal of this module is to give you some insight as to how data is collected upon which the smart grid will depend. Specifically, you will gain some experience conducting measurements from which power use can then be determined. You will also connect these measurement strategies to fundamentals from circuits, for example, the aforementioned Ohm's law. The rest of the module will be used to provide context to the topics of voltage and current measurement, transformers, and complex power. There's also a hands-on experiment in which you will build a current sensor so that you can conduct your own power measurements.